Writing chemical equations and balancing. So this is the second part of your February break assignment. And for this part of your assignment, you're going to be doing the same thing as you did on the other side, which is balance. But the difference is you do not have a chemical equation that is represented by using formulas. You have a word equation. So your job is to actually first write out this equation using symbols and then balance it. So it's going to require a little bit more work than the first side did. But this should be what we already know because this is what we just had our test on, and that is writing formulas for compounds, whether it be ionic or molecular. So how am I going to do this? So the first thing says zinc. So zinc is just an element. It's a metal. And metals are all monatomic, meaning that it's just one atom. So when it says zinc, I'm literally going to just write the symbol, which is Zn. So you're going to need your periodic table to make sure you know what these symbols are, and of course for charges too. So the next part says plus, so I put my plus, and this says lead 2 nitrate. So I'm going to look up lead, and that's going to be Pb. So I'm going to start up here because I need to write out a formula. So I have Pb, and this 2 tells me what the charge is because remember that lead is a transition metal, and so it can have multiple charges. So it tells us what the charge is. So nitrate is a polyatomic ion. So this 8 gives it away. I'm going to look on my table E, and I see that nitrate is NO3, and it has a -1 charge. So to put the formula for lead nitrate, I have to crisscross. So that's why it's so important you have to know how to write these formulas because you need to make sure when you're writing out a formula, an equation, that you put the right chemical formula for that element or that whether it be an element like oxygen, you need to know it's O2, or a compound, you need to make sure it's right or you're not going to be able to balance it. So to cross, I keep this guy together in my parentheses. I put my 2 down here. My 1 goes this way. So lead 2 nitrate should be Pb1, so I don't put my 1, and then NO3, that's an N, by the way, and 2. Okay, now yield is my arrow. So there's my arrow. We have to do the same thing now again for zinc nitrate. So zinc, there's no Roman numeral, which tells me that there's only going to be one charge for zinc. So I look it up and it's +2. Nitrate, again, so that's NO3, and that's going to have a -1 charge. And I know my N's look like W's, but we're going to do the same thing. We're going to cross this. So we have a 2 coming out here, a 1 coming down here. So this formula would be Zn NO3 2 plus lead. So again, metals are monatomic, so it's just going to be Pb. So this is the formula. Now I have to balance it. So to balance, we said we're going to split this down this arrow, and we're going to write what we have, and we're going to see if it's balanced. So when I split it here, I have, whoops, let's get rid of that. We have Zn, we have Pb, and in this case, since we have a polyatomic ion, we can keep it together, or we can separate the N from the O. So I'm going to keep it together to make it a little bit easier. So 1 zinc, 1 lead, 2 nitrate, 1 zinc, 1 lead, 1 nitrate. So this is actually already balanced. So my answer would be this. So zinc plus lead nitrate produces zinc nitrate plus lead is going to be completely balanced with all subscripts of 1. So that was the first one. The second one. So aluminum bromide plus chlorine yields aluminum chloride plus bromine. So first we're going to start here. Now this is an ionic compound. How do I know? It has a metal. So I'm going to look up my symbols and crisscross. So this is 3 plus, and bromide is just bromine, so Br, and when I look up the charge, it's -1. So I cross, and I get Al1, and then Br is going to be a 3. Whoop. Okay. And chlorine. Now, you would think that it would just be Cl, but Cl is part of Brinkelhoff, which is just an acronym to help us remember all of the diatomic elements. So when they say chlorine, they're always going to mean 2, Cl2. Now, that yields or produces aluminum chloride, which, since this is a metal and a nonmetal, it's ionic. So again, I'm going to do the charges and crisscross. So we already know Al is +3, and we look up chlorine, and it's -1, just like bromine. They're in the same group. And I'm going to get Al, whoa, AlCl3 plus bromine. Now again, you would think I just put Br, but Br is part of Brinkelhoff. So again, we have to put a 2. So looking at this, we have to balance. So we split it down the middle, or in this case, it's the middle, but we split it down the arrow. So we have Al, we have Br, and we have Cl. So on this side, I have 1 Al, 3 Brs, and 2 chlorines. I have 1 Al, 3 chlorines, and 2 bromines. So just make sure you put them on the right line. So if you didn't, you may have thought it was already balanced, but we actually do not have a balance yet. So these guys are the ones that are not balanced. And just like an example we did on the other sheet, there's nothing I can multiply by 2 to give me 3. There's nothing I can multiply by 3 to give me 4, and neither of these can multiply anything to give me 5. So I'm going to have to make these 6. So whenever you see one side 2 and the other side 3, it's pretty safe that it's going to be 6, unless that element is broken up into 2 different spots. Then you can maybe make it 4. But in this case, it's not. So what would I have to multiply my bromine by to give me 6? I would have to multiply it by 2. So I'm going to start by putting a 2 here. Okay, actually, let me use a different color so we can see it. So 2, and when I do that, I recalculate. So now I have 2 aluminum and 6 bromine, and I still have my 2 chlorine. So I want to do the same thing on this side. I want to make bromine 6. So to do that, there's a 2 right here. I have to multiply it by 3. So I put a 3 right here. And when I do that, this becomes 6. And aluminum's still 1, and chlorine is still 3. So I need to make my aluminums balanced and my chlorines balanced. So how am I going to do that? Well, my aluminum's going to be easier to balance because I can multiply something by 1 to give me 2. So I put my 2 right in front for the aluminum, and it's going to make aluminum 2 times 1, which is 2, but it's also going to make chlorine 6 because 2 times 3 is 6. And this guy didn't change, so bromine's still 6 as well. So we're almost there. But chlorine is not balanced yet because I have 6 on this side and only 2 on this side. So what would I have to do? I'd have to multiply 2, this subscript, by something, which would be a 3, to give me 6. So I put a 3 here. And I cross this out, and I have 2, 6, 2. So this would be my full and complete answer. So 2 AlBr3 plus 3 Cl2 yields 2 AlCl3 plus 3 Br2. So this is completely balanced using the smallest whole numbers. So 2, 3, 2, 3 cannot be simplified anymore. Let's do another one. So this one, sodium phosphate plus calcium chloride yields calcium phosphate plus sodium chloride. Now we have polyatomic ions again, so make sure you have your reference table. We have sodium. Actually, let me move this down a little. So we have sodium, which is Na, and it's a metal, so it's ionic. We need to crisscross. So most of these are going to be ionic. Phosphate, you look it up on table E. Why? Because we know it's polyatomic. It ends in ATE, and this guy has a -3 charge. So when we crisscross, the 3 goes for Na, and PO4 is just going to be 1. So I do not need to keep the parentheses here. So it's just going to be PO4. Oh, I just said we don't need parentheses, and I'm writing them. Okay, let's erase that. Undo. Okay, let's try that again. A, PO4. Now, this should actually be a 3 because we have to crisscross. So it should be Na3, PO4. This 3 comes down here for Na. So here's my formula. Now let's do calcium chloride. So calcium is Ca, and it has a +2 charge. Chloride is just chlorine, so it's Cl, and it has a -1 charge. So when I crisscross these, I'm going to get CaCl2. And I have to put a plus sign in between these two formulas because we need to separate our reactants. Yield would be my arrow. Calcium phosphate. So now we have Ca positive 2, and we're putting that with phosphate, which is PO4 with a minus 3. We did that before. So now when we cross, I do have to keep PO4 in parentheses because I'm going to have a 2 coming out here. Remember, we cannot change this 2. So Ca is going to get a 3, so it's going to be Ca3, and then PO4 needs to have a 2 for a subscript outside. Okay, and sodium chloride. So sodium chloride, we have Na, which is positive 1, and Cl, which is minus 1. And when we put them together, we just get NaCl. So just saving a little bit of work because we already had them written down. So this is my equation. This is the first thing I had to do was write out the formula. Now I have to balance. So when I look at this, it looks like it's going to be pretty tricky, but it probably won't be as tricky as you think. So we're going to separate this out. And since I have a polyatomic ion again, I'm going to keep it together. But if you want to separate the P from the O, you can do that too. So PO4, and then we're going to put Ca and Cl, and we're going to count. So I have 3 sodium. I have 1 of my phosphates because I have nothing outside parentheses. I have 1 calcium and 2 chlorine. On this side, I have 1 Na, 2 PO4s, 3 calcium, and 1 chlorine. So what am I going to do? Now to start, we want to make it, again, as easy as possible. So all of these are actually pretty easy because they all involve a 1. So you can multiply 1 by anything to give you what you have on the other side. So I can really start with anything. So we can start with PO4. So PO4, and the reason I'm starting with PO4 is because you may think, okay, let me start with Na. If you start with Na, you're actually not going to, you're going to have to start it over because if you put a 3 in front over here, so let me just show you what I mean. If you put a 3 out front over here, that's going to give you 3 Na, but it's going to give you 3 Cl. And if I have 3 Cl, can I ever make this side 3? No. So I know that that's not going to be the right answer. So I'm going to undo that. So you may have some trial and error here. So maybe you want to use pencil when you do this. Don't get frustrated. It's kind of like a puzzle. So if it doesn't work out, then start over. Start from your count and try to start with a different one and see if you can get it. So I'm going to start with PO4. I want to make this side 2, so I'm going to start by putting a 2 in front of Na. So I'm going to cross these guys out. Na becomes 6, PO4 becomes 2, and I still have 1 calcium and 2 chlorine. Now my PAs are balanced. So what am I going to do now? I need to balance my NAs, and I need to also balance my chlorines. So I'm going to balance my NAs by making this side a 6 because I am multiplying by 1. So I'm going to cross this out, and I'm going to put my 6 here. 1 times 6 is 6. PO4 is still 2. Calcium is still 3. And now my chlorine is actually 6 too. Okay, so almost done. My calcium and my chlorine are the guys that are not balanced at this point. So calcium needs to be 3 and chlorine needs to be 6. And because they're together and it happens to work out, that we can put a 3 here and it will make my calciums 3 like we need and my chlorine 6. And then these guys stayed the same. So I had 6 and 2. So now everything's balanced with my coefficients. So my coefficients are 2, 3, 1, 6. Okay. Last example. This example I want to do because it says hydrochloric acid, and we haven't talked about acids and bases yet. So I wanted to point out where you can find the formula to this. So in your reference table, if you look at table K has a list of all of the formulas for common acids. So you may or you will have to look at this for some of the other examples that have acids. So when you look on here, it'll give you the formula for hydrochloric acid, which is HCl. So I'm just going to plug that in right away because we don't have to solve for that. We can just look that up. So I'm going to go back and do aluminum. So again, aluminum's a metal. It's monatomic. They're never going to exist as pairs because metals can't bond with metals. So aluminum plus hydrochloric acid yields aluminum chloride, which is an ionic compound. So I have to look up my charges and I have to cross. So 3 positive, and chloride is just a chlorine ion, and it's -1. So when we cross, we get AlCl3. And hydrogen gas, don't let it throw you off that it says gas. That's just the state that hydrogen's in at STP. So hydrogen, again, we can't just leave it as H because it's part of Brinkel-Hoff. So we put our 2. It's diatomic. So here is my equation, but it's not balanced. So let's balance it. So Al, H, and Cl. So I only have 3 elements, and I got to make them balanced. So I have 1, 1, 1. So this should be pretty simple. And, oops, that's wrong. So my hydrogen's actually 2. So hydrogen's 2 and chlorine is 3. So just make sure, because you can easily make a mistake like I just did. And since this isn't the same order as this, put them in the wrong spot. So just always double check. Now, I can start with my hydrogen, but you're going to find that it's not going to work if you start with hydrogen, because if I want to put a 2 here, that's going to make chlorine 2 as well. And if this is 2, again, this can't become 2. So that's not going to work. So I actually have to start with chlorine. And again, it's trial by error. So if you start with hydrogen and it doesn't work out, then erase it and then try chlorine. So since chlorine is 3 on this side, I can think to put a 3 here, but if I do that, hydrogen's going to be 3. And can I make this 2 times something to give me 3? No. So that doesn't work as either. So this one's a little bit more involved. You have to think, what can I make that and have hydrogen and chlorine both be able to be balanced? So it's going to wind up being 6. So in order to make my chlorines 6, I'm going to need to put a 2 here and a 6 here. So I'll start by putting my 2 over here, and that's going to give me 2. This stays 2, and this is 6. If I put my 6 over here, I'm going to get 6 H's, 6 Cl's, and my aluminum stays 1. So now I have to make my hydrogens the same as this side. So 2 times 3 gives me my 6. Okay, so that's why we made it 6, because that was the only thing I could make them so that I could actually balance my chlorine and my hydrogen by putting a number here. So this is going to change. This is 2. My hydrogens become 6 and my chlorine becomes 6. So the only thing I have to do is make sure my aluminums are the same as this side, so I would put a 2 in front. So it becomes 2, 6, and 6. So this is balanced. So this would be my answer. And again, this is simplified. 2, 6, 2, 3. Can't be any simpler. So that is all the examples I'm going to go through. So you have the rest to try on your own. So don't get frustrated. It's trial and error. And go back and pause as much as you want and take these examples and apply it to the other ones.